do something else? Anything else? I have a thing to do, so no. All right, guys. So in your note packet, again, you have two different packets. One is notes, one is homework. Find this page in your notes packet. The notes look really long today, but they're just like very spaced because there's a lot of like diagrams and things going on in it. It's actually a pretty easy day. There's a couple things that I'll say you can look at the graph, but it's not like a lot of code. I think this is all non-math. All right, guys. So first, looking at the first graph over here, we're going to talk about continuity first. Do you guys know what a discontinuity is? Like a hole, not continuous. So if you were to trace this graph with your pencil, you'd have to pick your pencil up at some point, right? You have to do that on a graph, then there's a discontinuity. Okay? So the first one here, I'm going to call this, I'm going to say that's A. And I would say f of A is undefined. Okay, so like there's not a function value there. It's really not bad. It's Unit 10 is a lot of like mechanics of finding derivatives and limits and just, you know, there's a decent amount of algebra. But I would say it's more procedural. Unit 11 is much more like depth of understanding and can you connect. Well, now it's weird because some people, it's probably the test that I have the most 100s on.
Yeah, exactly.
But also that it's kind of like either you totally understand it or you
really think it.
Yeah. Hopefully no one will be on that side. All really understand. All right, guys, if we look at the second one here, I'm still going to call that A. Is this undefined for A? No, because there's a value, but it's still not a continuous graph, right? Okay, so I'm just going to say f of A is defined, but there is a discontinuity. Okay, so there is a discontinuity. It's not continuous, that's fine. Yeah, they mean the same thing. So guys, I think with continuity, it's very easy for you to just, like, you can look at this and say, yeah, there's a discontinuity, right? So what we're going to do with that is formally define a discontinuity or check for, it's called the continuity test. So we have to know if the function exists, which we're talking about already, and then we have to know something about the limits. So before we can get into the formal continuity test, we have to learn what a limit is, okay? These are not bad. It's a lot of notation, but it's really not that scary. Okay, so we would write the limit of f of x as x approaches A equals L. Okay, and then it's just telling you how to say that. I know, I'm sorry. Yeah, lots of notation. I should have said wait and write what I write, not what I say. What limits are is it's the y value that your graph is approaching. It's not necessarily what it equals there. It can be the value on your graph, but it's what your graph is approaching. So if we look over here, I always draw little people. So if I have this guy here, and he's walking up the hill, and then I have this guy up here, and he's sliding down the hill. Do you see, as they both approach this x value of A, how they have this y value of L, that's where they are? That's what the limit is. It's just whatever the y value you are approaching as you squeeze in on a certain x value. Okay. If that sounds weird, when we do a bunch of examples, you'll see it, I promise. Okay, so if we have this table here, and we really only need to look at y1 for right now. If I wanted to know the limit from this table as x approaches 3. Okay. So here's my x value of 3. I can't just look at the y value because it doesn't exist. Okay, there's nothing there. So what I would do is look as I squeeze in with these x values, what are the y values doing? Squeezing in on what number? 6. That's the limit. It's all what are you approaching? Okay. That's it. All right. So let's try a couple more. Let's say my equation for y1 here is just y equals x plus 3. Okay, can you graph the line y equals x plus 3? Tricky stuff. There's the line. So what I'm asking you for down below, it says the limit of y1 as x approaches 3. And you don't really need this other blank here, but it should be the limit of x plus 3 as x approaches 3. What do you think as I go to an x value of 3? And sometimes I draw like a wall in there. So as I look at that wall at 3, as I squeeze in on that wall, what y value am I getting close to? 6. That's it. That's the limit. Okay. Are you guys okay?
Yeah, I just don't know how to grasp.
Oh, that's the hard part? Yep, okay. All right, I'm going to make it even more complicated for you now. Let's say my equation is x minus 3 times x plus 3 over x minus 3. Oh, jeez. I know. Was it yesterday like so hard to...
I couldn't write it.
I struggled.
Yeah, at the end of the semester, so you're like, come back to school, your handwriting is completely
Like, you can't read it.
Summer's the worst.
Summer is not.
Or summer. That summer.
Guys, what's going to happen right here? Cancel, and what does that make?
Oh.
On the line, y equals x plus 3, so we get to try to graph x plus 3 again. It's clearly going to be a good day, guys. Okay, this is not supposed to be the hard part. Okay, so there's my graph. I'm gonna draw. Good job. I'm gonna draw a wall again at x equals 3. Okay. Not what does it equal necessarily as x equals 3. What are we approaching? 6. Yes, it's still 6. It doesn't matter that it's a hole. We're not going to have our little guys fall into the hole. They're just going to walk right up to the edge of the hole. Okay? And what y value are they at?
Oh, I get it.
Yeah.
I actually got that.
See? I know, it helps.
She says the guys are not going to fall into the hole, they're approaching the hole, which is 6. Or something like that.
Yeah, so like if they walk up to it,
If they walk
or
up
down
to
to it, they're gonna go stand right on the edge of the little hole. Okay? Either on the edge, they're not gonna fall in. Where are they?
The first graph we did,
How come what? I'm sorry.
the first thing we did is like with the whole thing. Talking about was very special.
So this is undefined at x equals 3.
Yeah.
Okay?
But
It still has a limit.
It's just asking where the y is.
Yeah, so this is not asking is it continuous, it's just asking what the limit is. Yeah. Yep. Okay.
How did you get to the whole
Those would cancel, and that's when x is 3 is where that hole would be. Okay. All right, guys, let's turn the page. Woo! We're only one page in, guys. Like 7. But they're quick. They really are. What? Can I switch, or do you still need it?
Oh, no, I'm good.
Okay. Okay. So we are going to find limits by looking at a graph. That's most of today. A little bit with tables, and then eventually we will get to finding them algebraically. We're not going to do that today, though. So really we just need to practice looking at this graph and figuring out what the limit is. So let's do A together. I'm asking you the limit as x approaches -5. So I'm going to draw a wall at -5. Okay. Draw your little guys if you need to.
Look.
What are they approaching? 4. That's it. All right, try B, C, and D for me.
You still that hole at that point. It's still approaching where the hole is. Yeah.
The point is just there to mess with you.
Ah.
Don't let it. I know. Just purposely mess with you.
I remember in like elementary school they gave you problems and they gave you way too much information that like you didn't use.
Just to like toy with you, yeah.
Yeah. And you had to like identify the important information.
Yep.
Does exist. I don't know whether it's approaching 0. As x approaches 0, it's approaching 0, is it not? Yeah.
We haven't talked about one like that yet.
See, look, 2. That's what I'm thinking. Is limit like 1?
But it's not approaching 8. It's just
Can there be more than one answer?
What? You know, like girls. The limit does not exist. The limit does not exist. When she's doing the math competition, and she's like, the limit does not exist. Oh my god.
All right, guys, let's go through B, C, and D. What'd you get for B?
3.
3, yes. Everybody okay with that? Were you thrown off by this dot? Okay. It's there just to kind of mess with you. If you think about it, though, if you draw the little guys and they're walking on the line, are they getting anywhere near that dot?
No.
Oh, they're approaching 3. If I had asked you, like, the actual function value, if I said, what is f of 2? Then what would you tell me? 5, yes, okay. So that's the only time the dot matters, is if I'm asking you specifically for the function value. Okay, letter C. I heard some 0s, I heard some 8s, and then I heard some mean girls. So what do we think it is? Mean girls. Yeah, it does not exist. Okay. If I put one guy over here. Wow, that's, I don't know what's going on. He's got weird hair. And another guy up here. So this one's walking this way. This one's walking this way. Are those two little people going to run into each other? No, so the limit does not exist.
You'll fall off.
I actually tumble over the cliff. Land on the other guy.
The train got
Okay, so if the two people don't meet, the limit cannot exist. Okay, they have to like be running into each other or standing on opposite sides of the little hole. Okay, well, you don't need to fall in the hole. But. All right, then letter D. What'd you get? 0. Yes. Okay. So what we were doing with that, especially with letter C, we were doing the limit from the left and the limit from the right. Like we're looking at those two different guys. That's something that we actually look at very specifically. Yeah. Sure.
So what if the line doesn't touch 0, but the top one does? Like there's a hole.
Like a hole right at 4.
A hole at x equals 0.
This? No, this one?
Yeah. So then
Still, are your two guys going to run into each other? Like, are they approaching the same thing? Look at, is this guy getting anywhere near where this guy is? There's a wall at 0, remember? Like, there's a wall there that will prevent him from falling. So he's going to run into the wall. He's up here at 8. This guy runs into it at 0. So they are not meeting.
If the guy's walking and there's a hole in his path as he's approaching something, does that mean it also can't at all?
Well, like, you're not going to draw him over here to approach. Okay? Alright, so let's talk about these little pluses and minuses. Okay, do you guys see this little tiny minus right here? Teeny tiny minus?
Yeah.
Okay? That is telling us it is the left-hand limit. Alright guys, so the second one with the little tiny plus next to it, what do you think that is?
Right.
Not right-hand rule, just right-hand limit. I know, yeah.
Pi over 6.
Alright guys, so let's look at left and right-hand limits here. Okay guys, way too many side conversations. Notes are not terribly long, we need to get through them, okay? Alright, so I'm asking you now to find the limit as x approaches 0 of the absolute value of x over x. I have given you what the table looks like there and what the graph looks like. This is really more what it looks like, but the holes don't really show up on your graph. So, because x cannot equal 0, so we know we have holes there. So if you're looking at this as x approaches 0 from the left, what would you tell me the limit is? -1, okay. So the way we write that, the limit as x approaches 0 from the left of our function is, I would not write the whole word limit. Like, I mean, you're not wrong, but, okay. And then what do you see is happening as we approach from the right? Positive one, yeah, so that's the second line. So the limit of f of x as x approaches 0 from the right.
Just because it has a plus or minus doesn't mean it's approaching from the positive side or the negative side. It just means like if all of the whole graph's in the negative, it's going to have.
Yeah, it's just left or right of that specific value. And that's the calculator part of it.
And you can just use cwtv.com.
All right, guys, so we've got a left-hand limit and we have a right-hand limit, but are they the same thing? No. So if I asked you just the limit of f of x as x approaches 0, not from the left or right, what would you tell me? Does not exist. They don't match, okay? So in our little box here, we're going to write kind of that rule. So the limit of f of x as x approaches a equals L if and only if, remember that from geometry? Ew. The limit of f of x as x approaches a from the left equals L and limit of f of x as x approaches a from the right. If and only if. You can write it like this way too.
That was all that was on my SOL geometry. It was like, if Claire likes to swim, but she can only swim when it's raining. It's not raining. Claire actually, it's so hard.
I did a job.
You have, like nightmares about inverse, converse, all that. All right, are we okay so far, guys?
Logical reasoning.
Okay. Turn the page for me. Try to do those 6 limits. There you go. Let's try to take attendance here.
So like, this isn't like something super big deal, but on my sunset, we just
Just approaching from the negative side. Approaching from the left. Here, it's one. If it's got a minus, it means it's coming from the left, from the negative 2. Yeah, so if it's coming from this side, where is it going to poke in the negative?
Yeah. So like, so let's say limit as x approaches 3. You've got your wall at 3. From the left just means coming towards that wall from the left. Yeah.
I would ask you from the left.
Oh, it's right?
C is.
I see.
All right, guys. Did you talk to each other?
Go. Like so.
All right. How do we do? Check for me up here, guys.
What?
This makes sense. I understand.
You understand? Yay.
It's better than no.
Yes. Agreed. All right. Any questions on those 6? Okay. All right. Now that we know enough about limits, we can go ahead and do the formal continuity test. So, you've got this written in your notes for you. Let me erase all. Okay. So when you go through a continuity test, if I ask you to prove if something is continuous at a certain value, you need to show me these 3 bullet points. Okay, the first, you would be telling me about the function value at C, that it exists, or you can tell me what it is. You can say like f of 2 equals 5. Okay, that's step 1. Second step is telling me about the limit at that x value, okay, which you now know how to evaluate. And then the third thing is if the function value and the limit equal the same thing, then it's a continuous function. So guys, real quick, let me just show you back on the first page. Remember we said we know this is not continuous. You didn't really have a way to show why. The function value is down here. The limit value would be up here, right? You see how those would not be equal? So that's how you know that it's a discontinuity. So let's go ahead and try one together. Okay, so the first one, determine whether f of x equals 1 over 2x plus 1 is continuous at x equals 1/2. justify with a continuity test. So our first one would be to find f of 1/2. We need to know, does it exist? If it does exist, what is it? What'd you say? 1/2? Yeah, if you plug it in, you get 1/2. So, okay, it exists. I'm going to jot that down. Yeah, like if I had said negative as x equals negative 1/2, because that'd give you a 0 in the denominator. So then you'd be like, nope, doesn't exist, can't be continuous. Okay. All right, so first bullet point, we're good. Second bullet point is about the limit. So the limit of f of x as x approaches 1/2. Okay. For right now, I'm going to let you go ahead and graph this one on your calculator. Eventually, we'll get to where you can just do this algebraically. You don't really know enough yet. So if someone around you has a calculator, go ahead and just graph it and look at it. Without looking at it? Like, what do you mean? Without looking at the graph? No. There's no, like, evaluating limit part on you can look at the graph. You can certainly look at the table if that's easier for you. You might want to mess with your table set. Do you guys know how to do that? Things like length there. Second window. And then we care about it at 0.5, right? And I'd maybe go by like 0.1s as your change in your table. For delta. Yeah. Or you can look at the graph and trace and see what you find. If you're doing your table setup, like the change in x.
Yes, that is what is supposed to happen. Yes.
How are we doing, guys? We okay with our calculators? Do you have the equation in here?
Oh my gosh, I never need to do that.
Error.
Yeah, it's pretty big.
I didn't really get that 1.2.
I would gladly
Yeah. I just recently. I thought it was Infinity War.
That's the one.
Okay, well, we want to really want to be able to
All right, guys. So what is the limit? 0.5. Yes. Okay. So are they the same thing? Your 2 bullet points equal each other, right? That's what the third bullet point is, just you telling me that. F of 1/2 equals the limit of f of x as x approaches 1/2. Therefore, which is just those 3 dots, f of x is continuous at x equals 1/2.
So we read this like out every I forgot what it was called.
Wait, what's that symbol for therefore?
Essential
Three
item.
dots.
What else? Essential
No,
item.
not assessing, it's on the, oh my gosh, I can't remember the name of
If they happen to be not equal,
Yes.
they're both going to
I
be the
something,
same.
I something.
Yeah, you'd say
And
not
you say
equal,
therefore.
the IGT,
IDT.
intermediate value, there you go. And then you'd say it's not continuous because. All right, guys, let's look at number 4 together. I didn't tell you what x value we're looking at. What do you think it's going to be on this one? 0, yes. So bullet point number 1. We need to know what g of 0 is.
2.
Are you sure? Okay, do either of these
Undefined.
actually include 0?
No.
Okay, so yeah,
Undefined does not exist.
does not exist. Okay. Yeah. And so therefore we know it's not continuous, right? Like you can stop there. You don't have to do the other bullet points. So therefore g of x, yeah, is not continuous.
But what if everything else does not exist as well?
It still doesn't work. It has to actually be a defined value. Yeah.
It's double negative. If you have 2 points that are undefined.
That makes 0 sense.
All right, so number 5. What do you think we need to start with on this one? Okay, so h of 2.
Oh god.
Still,
Oh god.
Still does not exist. So what are you going to tell me?
Therefore,
there.
At?
If you have a point that doesn't exist in the middle of your
Good. Okay. They aren't all going to be not continuous, okay? Some of them you'll actually have to go through all 3. Does the idea make sense, though?
How does the central one clear not?
No. The IVT?
Yeah, the IVT.
Yeah, 5. No, it doesn't. He was just saying we had 5 bullet points for that.
5 bullet points. Like, yeah.
Oh, right.
Yeah.
Oh, you have to assume that it is continuous.
All right, types of discontinuity. I think you've learned these in Algebra 2, but we'll go over them just in case. All right, infinite discontinuity. Do you know what that is?
It's when you have the asymptote.
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 Okay, and that happens where the denominator equals 0. So what it would look like graphically.
Where
If that's the graph you're given, you would tell me infinite discontinuity at x equals 3. You always need to tell me where it happens, okay?
What about a horizontal asymptote?
That's not a discontinuity.
Okay, why is it discontinuity? There should be a whole separate thing.
No, you could have like a horizontal asymptote in here, and your graph could do that.
But if you have 2 things on the sides, of course.
two things on the
Like,
side.
yeah, one,
That those things separate.
Okay, is that a function, what you're talking about?
It's that. Thing in the top right.
The horizontal asymptote has nothing to do with the discontinuous.
Okay, well, my friend tried to get us saying like,
You can cross a horizontal
for
asymptote.
like the first 2 days because she
Discontinuities have to do with your domain, not your range. Okay. All right, second one is removable. You probably call it a hole.
hey, I have some extra.
mozzarella.
Very good.
You don't eat bread. All bread is. You can only eat matzah, which is like a thin cracker that tastes like cardboard.
Sorry, where there exists a common factor of the numerator and denominator. Sorry, I just didn't like how I was wording that. Graphically, it might look like that. You would tell me removable discontinuity. So, like, things that would cancel out, yeah. So you would say removable discontinuity at x equals -2.
I'm out of my luck because there were so many good sales over
They really do land.
All right, guys, last one is a jump. This only happens with piecewise functions. How'd that review of piecewise go last time, guys?
Yeah, that was actually. Wait, you put that like the domain for it to the left, or is it?
Stop, I remember that.
I still don't know.
And this happens when the left limit does not equal the right limit.
I think you did that.
Yeah, it's a blade weight after that.
All right, you guys see how that's a piecewise graph? See how the left and right would not run into each other? So we would say jump discontinuity at x equals 1. All right, so let's look at 6. It says determine whether the function f of x equals 1 over x minus 1 is continuous at x equals 1. Justify using the continuity test. Discontinuous, identify the type. Infinite jump removable. Okay? So, first bullet point is to find f of 1. O does not exist. So therefore, f of x is discontinuous or not continuing, whatever you want to write. At x equals 1. What kind of discontinuity would that be? Okay, so infinite.
We have to.
Yeah, so infinite discontinuity, and again, at x equals 1. Okay? All right, we're skipping 7 and 8 for now. We may or may not come back to them at some point. So.
Like graphs and then have to say which one is different.
Yep. Okay. All right, next part. Now we have some unbounded limits. Okay, so if you have a vertical asymptote, and I ask you about the limit as x approaches that, and your graph is going to go up to infinity, okay? Is infinity a defined finite value? No. So you would want to tell me, hey, it's heading towards infinity, but really the limit does not exist, okay? So let's look at this little graph right here. That's what everything in that box is telling me. Okay. Much shorter. So if this is the graph I'm looking at, the left-hand limit. So as I follow it, we're talking about the limit as x approaches 3. Where's it going? Okay. So what you would tell me is negative infinity, comma, does not exist. What do you think you're going to tell me for the right-hand limit? Good.
You don't have to say positive.
Okay, what about just the overall limit? What would you tell me?
Does not exist.
Does not exist, okay? The left and right are not going in the same direction, so that is just does not exist.
You just really think
Nope, I'm not asking you the type of discontinuity, I'm just asking you limits right now, so it all depends on the type of question. Okay, we've already talked about this, but all of this giant wording in your box is just saying the left and the right hand limit have to equal each other for the overall limit to exist. Okay? Told you it was quick. Alright, now let's look at this one. So I'm asking you about the limit as x approaches 0, and we're looking at this graph. It's a slightly different graph. There is an asymptote going on right there. So what are you going to tell me for your left-hand limit?
Infinity.
Excellent. What about the right-hand limit?
Does not exist.
Okay. Now, be careful on the overall just x approaches 0 limit. What are you going to tell me?
0.
Infinity.
Yeah, both. Infinity and does not exist. So you're telling me, like, hey, both sides are going the same way, but it's to infinity, so it doesn't actually exist. Okay? Does that make sense? All right, okay? All right, let's keep going. All right, don't be scared because there's a cosine in this one. Promise it's not bad. All right, guys. With this one, if you graph it, it just looks like a line, okay? It looks like as x approaches 0, it would be 0. If you look at the table, though, it's not. And let's even think about if I were to just plug in the value of 0. So this is 0. Okay, and what's the cosine of 0? 1. So what's 1 over 1,000? Like, yep, it's 1 over 1,000.
0.
1,000.
Yeah, which is what that number right there is, negative 0.001. That is the limit. It's not actually 0. It looks like it from the graph, but it is negative 0.001. So you just have to be careful on those. You can't always just eyeball it from the graph on your calculator, okay?
It's really a straight line here, so we got.
Oh. That's all very close to 0. Okay, the next one, I don't know why it's on a different page.
Oh, look at this.
Okay, I'll just leave that one out. Okay, the next one we're looking at is the limit as x approaches 0 of sine of 1 over x. Guys, this is what the graph looks like. Okay? That is called a wildly oscillating graph.
Fair.
I don't know why it's necessarily so wild, but there it is. It's back and forth. Yes, oscillating wildly. If you have a graph that oscillates wildly, or mildly, really, if it's oscillating, then the limit does not exist because it bounces back and forth too much to really be considered approaching one specific value. Okay? So that one does not exist.
So it just give us a graph that's oscillating or something that
Why?
we don't figure it.
So I want to know,
What?
how do you make it show curves better? Instead of like cube, like you know how like in circles it does.
Make your window really small.
Yeah, make it small.
Then maybe it's a line.
How do you make it possible? Oh, wow.
Yeah, it's not. Okay, so there are a few times that the limit of a function does not exist. And that's what I have written for you here. Let me erase down Okay, so the three ways that it will not exist if it oscillates wildly, okay, the left and right are not equal, and if it doesn't approach a finite value. So those are those ones that go up to infinity.
Wait, why is it that when it oscillates?
It's not really approaching a specific value because it's bouncing back and forth so much, so you can't consider that to be a limit that exists. Okay.
Negative 2 to the right. Oh, I it's so 0.
All right, guys, try those
Oh no, from the
through
left.
I down below, okay?
That's one. Left. Negative 2. Left. Negative 2.
As X goes to the right, it goes to
All right, guys. We'll go through them after lunch, okay? There is one, yes.
Why did you say that? No, it's just when I confused.
Yeah, so really this graph like keeps going that way.
I keep looking at it, it's bothering me. No.
All right, guys, are we ready to see answers? I think I can make them all come back. Maybe I shouldn't have written. There we go.
Why is E infinity again?
Why is, sorry, I'm fine. E as x approaches 3. That just does not exist.
No, but why is it infinity? What number?
You said letter E.
D.
Letter D. That says as it approaches 3 from the left.
Oh, she's super smart.
Yeah. See it? Negatives are tiny. Questions, guys? Any of them?
Why is it A1?
A1 half. I don't know. It's close. If you put a half, that's okay. It's not a perfect grid that you can read it on exactly. So I would agree that right here looks like the bottom of it looks like a half. The 2 is a little further along.
It's different on mine.
Oh, looks different on yours? Okay. All right, any questions before we talk about homework? Okay, so find your homework packet.
Why are they two separate packets?
Oh, yeah.
Miss Rowland actually made my copies for me, and she just put them as 2 packets. So you like it as 2 or not as 2? No, you like it better when it's all.
It's hard to know.
Yeah, homework, notes, homework. Okay.
Let's label.
Was that what we studied?
Let's label this homework. Let's label this class. Look. It's young innovators. Like this? Oh, it does.
All right, guys. So the first page, the type 1 homework starts on question 142. So the numbering is obviously interesting. You're gonna do all up front and back. That first page. It looks like a lot of problems, but guys, it's just limits from a graph like this. Okay, that doesn't take a long time. It'll just give you good practice. Okay. Then, if you go on to the continuously considering continuity, the first 4 questions, guys, you got to pay attention, or you're not going to know what to do on your homework. All right, are you looking at the continuous continuity stuff? Here we go. Question 292. All right, it says examine the graphs and explain why each is discontinuous at x equals a, and then tell me the type of discontinuity. So you're telling me like which bullet point from the continuity test doesn't work. Okay, that's what you're doing on those, and then telling me it's infinite, it's a jump, it's a hole, whatever the type of discontinuity is. And then at the bottom there, let's just do evens, 296 through 302. Again, it says determine the values of the independent variable for which the function is discontinuous and justify your answer. So you're going to tell me like, okay, this is not continuous at, x equals 1, and then go through it's because of whichever bullet point from the text. Okay? Just so you know what you're doing on this. All right, that's it then for homework, guys. You've got time to work. I'm done. I'm really close.
Sorry.
Do you have anything that needs to be graded or
And all the grading is stuff I have to grade. I'll have like my TA or somebody go through and just circle if it doesn't match my key, and then I would go back.
Yeah, remember I graded the pre-calc regular, their like sign stuff, or their cosine cosine, and I was so confused because they would do different like interval factors, so hard. Yeah, do it.
That's the thing
Oh, you're left-handed. Ew.
I'm a disease. We don't want to stay. Only genetically superior people are left-handed. Genetically. I mean, my left-handedness was from my grandma who had cancer. Like genetic cancer, so breast cancer.
Yeah, you're not getting breast. I can get breast. Yeah, very rarely.
With the name. Totally.
Is your son okay?
My son?
Yeah.
Yeah, he's doing good.
I saw the picture.
Oh, yeah, how's it going?
It's still broken, but you know, it's getting fixed. Yeah, he just got x-rays again yesterday. 4 more weeks and he gets, so, break it into multiple pieces.
Are you gonna count?
Depends what. I'm gonna get gas costs. Oh, we had friends.
Sleep this much. No one has any cell phone.
What do you mean? Me and Griffin are
Yeah, that's not how I just like how.
Oh, that's why.
I know. I was gonna explain, it's like, okay. You don't understand, David, it's just like.
He's not a math teacher.
It's
a law either.
I didn't figure that one out. Yeah. I'm gonna do like.
So D is like the Y value right here, C is probably here. So as you approach 0, it goes into a Y value of D. It's weird when they're numbers instead of instead of the other way.
No, like, somebody would take a cover over like yellow burner.
I know.
Okay, the thing is, the relationship between us now is just,
Because they used to other apps.
it's so not fair. Even if I don't want to help, I would have to so much. I'm a history teacher.
It's isn't it bad? It's like a secret races.
Yeah, I really do. He does.
Much better.
He hates me. Exactly. I mean, no, solve it. He's not exactly.
I'm so nervous.
Well, shit. Alright, I'll take pity of her.
I'm feeling like I'm college. I think I'm just really down.
My mom knows everything about him, and she's the one that
Oh, like she did.
I have to be her.
An auto drawer. An auto was the biggest
I'm not gonna expose myself.
No. Okay, this year I had no Wait, let's see. I don't remember you teaching.
There's 6, yeah. 6. 0 is not there. So good. Right, -4.
How she hates me, like, I mean, no, I don't think that that's what hates me. I just like.
Why does
She's like,
why does everybody have to hate
and she like
My concert's like
What should you guys have anything?
You're like angry about that.
I'm not angry. I'm just saying.
Oh, okay, I'm like.
No, I really like that. It's remarkably good.
No, you should actually really. I like.
It's so nice.
This is like the new one. I think all of the ones.
She's not much better.
Okay, why did you need to switch those?
Like, okay, well, right before I wanted to not do econ.
Okay.
And so I wanted to like switch to a harder, like a different, I don't want to do econ when it's higher, but like.
Why'd you sign up for it?
I don't know. I'm just like classes now, like, I don't know why.
Yeah, but like she's not letting you.
Fourth quarter.
Part of the issues are like years.
The black, yeah, like
Numbers are super tight and things, so it's like.
Yeah, but like no, but she was like, I'm okay. Like I can't do this.
Interesting. I don't think that means she hates you.
Okay.
And then you want to have to do all the work.
For my solid, we're gonna help you with tabs. We don't know what.
He's just sitting in his office sweating.
I can't even ask him for answers, but I'm like, I don't know how to do it. Leave it alone.
It's gonna happen.
His sister goes to very good. Yeah. That's just not bad.
Yeah.
Who said that?
Someone's just makes that up.
Solid is the rule.
Did you have any politics, Colin?
No, I don't know.
You don't have any?
Actually, I might have to maybe say left.
Oh, yeah.
I'm getting rid of all my volleyball. Why? I love that.
Are you not playing? No, it's just I think that.
Oh, imagine having two of these.
No, it doesn't fit. We have my same question every week.
Oh.
That's
the
problem.
That's a personal problem.
Question.
I have
What
no idea.
do I say for this value? So it says it's approaching 0, so that'd be
Because we have to
that.
buy a new house.
Which is D.
Oh, okay.
D is like the White House.
Okay, thank you. I just
Yeah, I know, they're,
D.
it looks weird.
Thank you.
Yeah.
Yeah.
So, for the first one, it's like approaching 5.
They're both
But it
small.
doesn't really touch 5. 5 doesn't really
No, it's 5. Just 5 is the defined value. And again, it's when it's approaching.
Okay.
It doesn't have to actually be equal.
Okay.
It's when it's infinity, because that's not.
I think you have like 10 pairs of the same, like, pants, like, every day.
Yeah.
So it's like it's a person from the left like the graph stops at one.
So, wait, it's okay, it's like,
Like, if you wear t-shirts, well, you should have for the day, like, where you like practice or something. At that time, yeah. But like, they have, like, you know,
Yeah.
I just see the titles on cover, it doesn't get this.
I really stared at this for like 5 minutes. I'm in the morning. No, that's just the lab. I need to know how to do stuff on the lab.
Wait, Leah, do you know what to do for the lab?
You made me sit out there in the lab. So it wasn't very good. Work it out. You need to work that. It was me and Mira.
I was going over for yesterday, so I was like,
I was thinking about this. Okay, he's never called me on it before.
oh no, yeah, you're allowed.
Yeah, because you're using HCL there. How do you go back?
At first, like when we did that lab, I thought this girl was checking us into like thinking that I was checking for a guy. This is how we're supposed to be in a lab, like how we were supposed to do well, because it didn't look any different. Nothing was happening when we put the metals in the water. So we thought that was just like a joke.
Why would she go to this trouble?
You're making it forward. I hate you. Why? It's getting better. Literally, like, we're going on the block.
Raphael. I love him. No, I'm not doing my own. I hate my job. So people eat Raphael. What? How? He's like a lizard.
181 is that.
That's why you hate it?
Also, because I don't think Peter can for each other. Oh, wait, you're right. You're right. And it's gonna cost Bryce and Mateo's life. It's Teo. He's so annoying.
Oh, you know what I'm looking at.
Did you say 183?
She's like dating Spanish Jorge.
Really?
No,
You're
well,
almost very
she's like in love with Spanish Jorge, and then he's like doesn't like her back. But they're having to things to contested immigration officers or whatever. Yeah, she did, but the guy that Jorge doesn't. So like. No, she likes him, but he's making liking her to get his green card. No, she knows that, like he's not like it's not like to make it convincing to like the immigration officer say that he's like writing her like fake love letters and stuff, and she keeps thinking they're real and stuff like that.
So wait, she doesn't.
No, she does know that it's.
But she has for him.
Yes.
So like that is driving her. Really not.
Come on, follow that.
Yeah.
See, she likes him, so she's pretending to secretly like him, so that she can get her, he can get it away. She has a room.
Wait, who? Nicole?
Wait, how are you together since last single date? I don't think you have been breaking up, if you remember.
Because we couldn't work it out, and I was just like, sorry, I can't do this anymore, I'm sorry. And she was like, oh, okay, I'm gonna.
She's like, oh, okay.
You guys like talk even in person?
Yeah, we had
FaceTime? Are you talking on FaceTime or anything?
Wait, don't let me say having never spoken before.
Never talk to each other in real life. Even if the late is like.
No, I'm just like laughing at how everyone's involved with poor Sullivan's love life here.
I don't understand.
You guys like how it's like together.
Would you like to see that?
Take out of this. They're both my students, so that's just fair.
That's perfect. I'm so pissed. I can see you intention.
She said that's supposed to you. Wait, who?
No, they made it safe. It worked, dude. It worked. She's in your cousin's
My group was supposed to get ready, so I skipped for 5 hours. And then they didn't even like get the guys. The judges were so tired. They like.
Bye, guys. Hey, and I do have your test. Like, I'm writing the scores on it right now, so if you want to know after school, you can stop by and see them. Okay? They're almost all of the pilot.
How does this apply to the real world?
It doesn't.
I was supposed to because I feel like
We got it.
sit there for like 6 hours. Like my experiment was exporting a motorway through the
Checking viscosity.
Yeah, actually.
Mine was putting different gases in a ball.
How'd that go? Yeah.
I'm gonna let you know. So, so when there's two or more and exponent greater than 2 or more, right? I know, that's what I was doing. You were like, is it I know, that's what I was doing. If the square is like 3, well, no, it's only if it's if I guess, or it's asking me like all motivate, like in the middle like that. Oh, I have them. I'm not saying. I say you.
Sophia.
Yeah. Oh, now I have them. I have them too.
I'm like, should I go to see or not go to see? Like, happy. But the exams are like, it's so like, you know, like I tried. Like everything, I have to do everything going back to
Oh.
Yes. Is there anybody else who needs to make up the test?
I have a question. So, tomorrow my first period, I have a God study class period. Can I just take it then? I wasn't here like 2 days before break. Because I was out of school. I didn't realize that the test was on that Friday. I didn't know anything of that. Is it not possible? Okay, I can do it. It's okay.
There's no calculator.
Sorry, I gotta find my extra.
But it's a square root and the exponent's greater than 1, right?
You know, it's greater. It's out there. I'll bring it up to you in a second. I don't know where I put mine.
Should I bring like the best stuff?
There's one out there, so one of you will have to take it down.
I completed that 240 too.
Okay. It shouldn't be an issue. It's not that long.
And then, like, it's like,
Yeah.
I said that I'm gonna speak to like that. I don't know what choice it is.
I'm gonna go to my case. Anyway, do you want a packet?
Library. You know, wow. I'm like, I don't know, start. Yeah, that's it.
All right, guys.
Oh, it's just great. Where do you almost?
How's your son's video?
Star. It's good. He's still in the cast. He's got like 4 more weeks in the cast now.
That's not bad.
Yeah, he's doing fine.
His first of many.
Actually,
Second of many.
yeah. Much worse break.
Worst injury I got during the spring break was like I was stunned. It's like, yeah.
I do. No, it's because they're not on it yet. Which that's okay. You.
Oh, that's us Amy
Okay.
There's names of bananas. It's bananas. No, it's not. Oh, it's like.
So what's your science for next year?